Hello, this is Mr. Huber. In this lesson, we're going to look at hyperbolas. Hyperbolas are like two parabolas that open away from each other, as we'll see in these examples. And we're going to notice their equations are similar to ellipses, but they are different. We want to make sure we know those distinctions and differences as well. So here we see a couple examples of hyperbolas, ones that open horizontally, left and right, and then vertically, up and down. So you want to notice a couple things here. The parabola is actually this curved shape, right? It looks like a parabola. It's a hyperbola. It's got kind of a parabola opening to the left and then one opening to the right, the solid lines there. These dashed lines are for some other things we'll talk about in a second. Or it could open down. Okay, there's a hyperbola opening down and up. Okay, so that's a vertical hyperbola because you have one part of it opening up, another part opening down. So recognize the difference in horizontal and vertical hyperbolas because you can see their equations down here have some differences. Okay, when we look at a hyperbola, okay, the key things we want to look for are the a values, which is how far the vertex of this side of the hyperbola is away from the center. Okay, the b value, which will tell us, similar to an ellipse, like a covertex, okay, that tells us how far we go up and down, in this case, away from the center. And this b value and a value, where they meet, okay, we can draw an asymptote through those, so we know that our hyperbola opens and it goes close to this, but it's not going to go across it or anything like that. Okay, so the a value is on, like in an ellipse, on the major axis, right? The way that in the case of an ellipse is stretched out, or here in the case of the hyperbola, which direction it's opening. Okay, then our b value and the c value is a focus. Like in a parabola, we had it opening around a focus. Okay, we're going to have two of them, because on both sides of our hyperbola it opens around the focus. So we have our a and our b value and our c value. And we could see very similar to what we've seen before in different situations, some of these other conic sections. Right? And down in our equations here, x squared over a squared minus y squared over b squared equals 1. So we can see it's always going to equal 1. We're familiar with that with the ellipses. Over here, y squared over a squared minus x squared over b squared equals 1. So again, we want to recognize here, when it's opening left and right, the a value is under the x. When it's opening up and down, the a value is under the y. Okay, but we have to make sure that the a comes first, because subtraction order matters. When we talked about ellipses, it didn't matter. If you add 2 plus 3 or 3 plus 2, it's the same. Here, if we subtract, order matters. So the a squared is always going to be in the first term here, and depending on if it's opening left or right, it would have an x. If it's opening up or down, it'll have the y. Another difference, in this case, c squared equals a squared plus b squared. Ellipses, it was a minus. Now we have c squared equals a squared plus b squared. Here we can use that here with our c value, a value, b value. Those are our key things that we're going to look for. And let's see how they tie in more specifically here with these hyperbolas. In the first example, what is the equation of a hyperbola centered at the origin with vertices at plus or minus 12, 0 and focus at 13, 0. So I'm just going to draw a quick sketch. What might this look like? Okay. So 12, 0 and negative 12, 0. That'd be the vertices. Right? That's this right here. 12, 0, negative 12, 0. Focus at plus and minus 13. So that's going to be just outside it. That'd be a focus. That'd be 13, 0. There'd be another one over here at negative 13, 0 as well. Doesn't matter if they give us one or both of them. The key is that it's going to open around the focus, right? So on this side, it'll do the same. And so we want to make sure we know this means it's opening left and right. That's the biggest key to this. And now we have an a value of 12, a c value of 13. So we need to find the b value. To be able to write the equation, right, we need the b value. So now we're going to set up c squared equals a squared plus b squared. That's going to be 169 equals 144 plus b squared. Do that over here. So that's going to be 25 equals b squared. So b equals 5. Or actually, more importantly, we can leave it as b squared, because we write our equation, it's going to be over b squared. Okay, so when we do write our equation here, we want to recognize this opening left to right. That means our x squared comes first, minus, and then we have our y squared, and equals 1. And so now we want to fill in here our a and our b, a squared and b squared. So our a squared is going to be 12 squared. That's 144. And our b squared, so our b is 5, b squared was 25. So there's our equation. It opens left to right, so we have the x squared first. We use the a and the c values that we have there to help us figure out what b was, so we could use our equation, x squared over a squared minus y squared over b squared equals 1. All right, let's look at another example here, and we're going to do some graphing on this one. So we're going to graph this hyperbola. One thing we'll notice as we look at this is that it's not equals 1, so we need to correct that. We need to fix that and set this up equals 1, so we need to divide by 36. Everything by 36. Everything by 36. So we're going to have y squared over 4 minus x squared over 9 equals 1. Okay. So y squared over a squared. So if a squared is 4, a equals 2, and b equals 3. Okay. So you notice something here. A doesn't always have to be bigger than b in this case. Okay. That just tells us which direction it's opening, up or down. Okay. If the a is under the y, that means it's opening up and down. But a does not have to be bigger than b. All right, so in this case, we want to draw the graph here. The other thing we'll need is what the c value is, because we need to know where the focus will be when we draw this. So let's solve for that, and then we can work on the graph. So we're going to have c squared equals a squared plus b squared. So 4 plus 9. C squared equals 13. So c is the square root of 13. Okay? The square root of 13 is about 3.6. So that'll be enough to get an idea of where that focus is going to be when we draw this out. So let's put our axes in here. I'll draw them in green so we can see them nice and clearly. So we have our y-axis and our x-axis. Okay. And now if we're going to graph this, okay, so the a value of 2, so from the center, the origin, I'm going to go up 2, and then I'm going to go down 2. Okay, those would be my vertices. My b value of 3. So what I want to do with that is come out here to 3 and draw a little dashed line. It's going to make a box around here, and we're going to go out to negative 3. So I got that little dashed line. Again, I'm going out here to 3 and negative 3. Okay, from my center, my a value went up and down 2. I knew to go up and down because it was a y squared in my first term. Then 3, I go over to 3 and out to 3, and I want to make a box that goes up 2, down 2, right 3, left 3. So I'm making this little box around here. I'm going to have asymptotes then that go through the corners of that box. So I'm going to draw an asymptote that goes through this corner and this corner like this, so that my parabola, I know where it's going to, kind of how it's going to open. So I'm going to draw an asymptote through there, and then through here. And let's put our focus in there, and then we can draw the curve. So my focus here is going to go 3.6 units away from the center. So I'm going to go up from the center, from 0, 0. I'm going to go up 3.6, so right around 3.5, maybe a little more than that. So that's my focus. Down 3.5 here, that's a focus. All right. This is a vertex and a vertex. Okay. Now when I draw my hyperbola, draw it like a parabola, okay, I want to come out this way and go close to that asymptote but not cross it. All right. So that gives me a guide for how I'm drawing my hyperbola. You notice it comes out this way. It's not going out this way across this asymptote. That's kind of telling me how wide or narrow my graph is going to be. Right? That's kind of limiting where I can draw that side out to as it curves out and approaches, it goes close to, but doesn't reach the asymptotes. So I've graphed it, I've identified vertices, right? So identify vertices, vertex, vertex. Identify the foci, focus, focus. And I've got my asymptotes drawn in here. So when I graph the hyperbola, it approaches them but doesn't reach them. Right? So again, remember, A value, B value, right? This is the direction we move either left or right or up or down. Since it's under y squared, it's moving up or down. Up 2, down 2. The B value then is going, in this case, left and right to give us this box. We go out 3 on each side, and we make a box here that goes out 3 and down 2. Out 3, up 2. Out 3, up 2. Again, it's 3 in the x direction, 2 in the y direction. Draw your asymptote through the corners of those two boxes. So when you are drawing your hyperbola, again, it looks like a parabola, that curve there, you know kind of where to bring it out to on either side. So a lot going into the graphs there. Again, A's and B values are important, and then the C value for labeling the focus as well. Okay. Let's have a third question here about Mount Everest and other mountains. Before Mount Everest was discovered, what was the highest mountain in the world? A little bit of a tricky question here, because before Mount Everest was discovered, it was the highest mountain in the world. It didn't get taller just when it was discovered. So Mount Everest was the highest mountain in the world, even before it was discovered. All right, and Mount Everest has an altitude of 29,035 feet. Pretty tall up there. It's in the Himalayas on the border between Nepal and China, if you're curious where that is. And if you look at this picture we have here, right, looks pretty majestic and beautiful. Hard to know like how far away are you, how tall is that really? This little car right here, out on the road. Look how tiny that car looks, you know, with that huge mountain in the background. And then another shot of it here. Okay, you can see. So again, Mount Everest there. The second highest mountain in the world is K2, which is on the China-Pakistan border, and it's about 28,251 feet. So give you an idea there. Mount Everest and K2. And in North America, Denali is the highest mountain. It was formerly called Mount McKinley, but it was officially had its name changed so it could go with the native naming of it, Denali in Alaska, and it's 20,310 feet. So if you're curious what the largest one is around here or in the United States or North America, it's Denali, which was called Mount McKinley before it officially had its name changed relatively recently. All right, let's look at another hyperbola question here. I want to write the equation of this hyperbola and then sketch the graph. Okay, so if we're going to write the equation, we need the A value and the B value. If we're going to focus, that's a C value, right? So we want to recognize in this problem that C equals 10, vertex 6, so that's A equals 6, right? So now we need to set up C squared equals A squared plus B squared, okay? So we're going to have 64 equals B squared, so B equals 8. So now we've got our A and our B we can use to write the equation. So we'd have, does it open up or down? Be thinking that, right? Because that's what's going to come first, right? So if our vertex is at 0, 6, 0, 6, that means it goes up 6, right? So that means it's opening up and down. So it's opening up and down. We're going to have a y squared over 36 minus x squared over 64. Okay? So vertex 0, 6 and 0, -6. Okay? So let's see what that graph might look like. I'm going to move this up just a little bit, make sure we see all of that graph. So we're going to draw in our axes here. All right. So we've got our axes drawn in here, and now we're going to need to graph this. We're going to go up and down 6 from the center at the origin. So I'm going to go up 6, I'm going to go down 6. You just space that out a little bit. I'm going to run off my graph here. I can tell with my focus opening up or down, going above 6 there, but we'll fit that in, okay? And then our B value of 8, so we're going to go 8 to the left and right. That would be right here. And that's going to help us get our box drawn in. And over here. So we're going to have a box drawn in that looks like this. Could have gone by 2s as well. Is another way to fit this in the graph maybe a little better. Okay. So now our asymptotes would go through the corners of that box. and our focus is going to be 10, so I'd go up and down 10, so it's going to be, up here for our focus, and then down 10 there for our focus. We could label this our vertex here and here. All right, our vertices are points there at 0, 6 and 0, -6. And then I'm going to draw my hyperbola. It's going to go out this way towards the asymptotes, never reaching them, but approaching them. Okay, so we got an idea there from the information we were given. How do we write the equation? We need an A and a B value. We knew the A value and the C, we can find B. Okay, remember the vertices are on the A, opening, which way it's opening. Okay, so we got to make sure we know if it's opening up or down or left or right, so we know if it's the y squared first or the x squared first. And then we can have our A and our B values in our equation, right? And when we go to draw the graph, the other key thing there is that B value then tells us how to get the sides of that box to give us our asymptotes, so we know we can draw the graph accurately and make sure it's kind of approaching those asymptotes and not crossing them. Right, so as you continue to practice this, know the equation, know how the A value, the B value, the C value tie into this, again, how we can work with the graphs as well, and we'll continue practicing more with hyperbolas.